Hi, everyone. So, in today's lecture, we are going to be looking at air pollution in New Jersey. We're going to start by looking at how New Jersey monitors air pollution. We're going to look at the status of New Jersey air. And then we're going to look at indoor air quality, and some things you can do to improve your own indoor air quality in your homes. So, New Jersey Department of Environmental Protection, Division of Air Quality, maintains 31 ambient air monitoring stations, and you can see their location on the image over here on the right. And with these monitoring stations, they monitor those 6 criteria pollutants that we talked about, right? Sulfur dioxide, nitrogen oxides, carbon monoxide, lead, particulate matter, and ozone. And they also monitor hazardous air pollutants, right? The VOCs and metals that are produced in smaller quantities but are toxic, right? Very toxic, very hazardous. And they do that in a number. These monitoring stations are a little bit different. They have continuous monitoring stations, which we're going to look at in the next slide, that send data every hour to a website, and they send that to the EPA as well. They have stations that are filters that collect pollutants over a period of time, and then they get them analyzed at a lab. And then they use smaller containers. These are more for hazardous air pollutants. I actually use these are SUBA containers that you set up at different sites to measure hazardous air pollutants. They get collected and sent to a lab. Like I said, a part of these 31 monitoring stations, 18 of them are continuous monitoring sites. And they collect data every hour, and they upload that data to a website, which we're going to look at in a second. And they also send it to the EPA. And you can go onto these websites, the New Jersey website, and look at this data. And the EPA also maintains an interactive map where you can look at air quality countrywide. Now, before we look at these, I want to make note of something. There is something referred to as the Air Quality Index that you're going to see on both of these websites. And it's essentially a way of standardizing the ambient air quality standards, right? And making them all equal to make it easy for viewers to assess their air quality. So, what do I mean by this, right? If you remember, we have ambient air quality standards, right, that limit the amount of pollution that we should see in the ambient air, the air all around us, based on looking at those 6 criteria pollutants, right? But their levels are different. Their standards are different, right? Carbon monoxide over an hour, we want to limit it to under 35 parts per million. But if we're looking at nitrogen dioxides, we want to limit that to under 100 parts per billion, right? So different standards for them. So if we're trying to compare air quality and make this easy for viewers to see or the public to see, we don't want them to have to remember these different standards and then tell them the actual numbers and then have to look up the standards. We want to make it easier for them. So they developed this air quality index. And essentially what they did is for each pollutant, they set this standard at 100, right? And so then anything below that standard would be good quality air or moderate to good, right? And anything above it would be bad. And then this way, they made it all equal for them. So if you go onto these things and you see, and they color coded it, so if you see green or yellow, you'll see that your air quality is essentially below standard, right? And that, again, if you need to get specific, we can look at the specific ones, but it's just letting you know an easy visual way of identifying whether you have good or poor air, and ideally for the public, right? To make it easy for them to consume. So let's take a look at these links and see what kind of data we can look at. So we'll click on this one. So this is the New Jersey air quality website, air monitoring website. And you see here, it maintains a map of the latest data as well as a table of that data as well. So we'll click on the map for now. And these are the 18 monitoring sites that are continuously sending data every hour. And if you click on them, again, this green is going to be that air quality index. So if we see green, we know that our air quality is good. It's below these ambient air quality standards for what we're concerned with. So if we click on each individual one, it'll tell you the index value, right? And then we give a number for it. But then it also breaks down the individual pollutants that it's measuring, right? In this station, we are measuring those nitrogen dioxide, ozone, and sulfur dioxide. And you can see within the last hour, we had no values for the 2 of them and a little value for ozone, right? And you can collect more information about the station. And you can do this for all of your different stations, right? This one, some of them, they don't all measure the same pollutants, right? Some measure more than others, but you can collect information on all of them. All right, so this is a good way of testing or seeing what your air quality is in different areas, right? We're probably closer to over here, campus. It's probably the closest one in Camden, and you can see these values, and this is more of an urban area as well. So that's one way. You can look at the map. If you went over here, you can look up, this is the actual data in tabulature form, and you can see each station, the data it's collecting, and the values. So it's a way that you can assess air quality within the state, right? Really nice resource. And again, I said that the EPA also monitors this and monitors data, and this is more of a countrywide, right? So this will look countrywide, what your different air quality is in any given moment. And they are focusing on ozone and particulate matter in particular, right? So you can see really it's more than countrywide, right? Because it includes Canada and Mexico. And you can assess air quality, right? And it'll tell you, I don't think it tells you as much data, right? It just looks at the air quality index. But another resource for you guys. Okay, so that is the current status of air quality. If we want to see what the current status of air quality is in New Jersey, right, we go to that website, we can look at that map, we can look at that tabular data. What about historical data, or what about summary data? And we can collect those, again, from that same website. The DEP also produces annual air quality reports. And you can go and you can look at individual reports, right, and they keep a history of them. Or you can look at the most recent report, and it generally summarizes data over the past several years. And that's what I'm going to show you here. We're going to look at the 6 criteria pollutants, and we're going to see how their levels or how their values have changed as the years have gone on, right? So if we're looking, we're going to look at lead, and we're going to look at lead concentrations. And you see from this graph, you see that in New Jersey, we have done a good job of reducing our lead air concentrations. Again, a lot of this is related to that reduction of leaded fuel, right? We got rid of leaded fuel in our gasoline, and that has gone a long way in reducing lead air concentration. So you can see that where we are now, we are below standard. And you can also see what's important is that our standards do change. I mentioned that in the last lecture, right? But as the EPA evaluates more information, they do change the standards, right? Or the ambient air quality standards, right? As we learn more about the health effects, as we get better at cleaning up pollutants or reducing emissions, these standards do change. And you can see that change occurred here in 2008. And it reduced the lead standard, but we are still way below that, really not producing much lead emissions, which is a really great thing. Again, we've also done a good job with carbon monoxide. You can see this drastic reduction in carbon monoxide. If we go back to the last lecture, the ways we stop carbon monoxide, we put those catalytic converters in our cars. That transportation fuel was one of the big ways. Right, and that catalytic converter converts that carbon monoxide to carbon dioxide, which again, maybe not the best thing, but it is reducing carbon monoxide emissions. Again, besides just that, any burning of fossil fuels can produce carbon monoxide, so that's switching from coal to natural gas, which doesn't produce as much CO emissions, is effective as well, and the increase in renewables. Nitrogen dioxide, same thing. Again, if we're talking about those car emissions, nitrogen dioxide is one of the big emissions. That catalytic converter did a great job. We also have those scrubbers that we have in power plants and other industrial processes to scrub out that NO2 before it gets emitted. And we are well below ambient air quality standards for nitrogen dioxide. Sulfur dioxide. Now, this is actually pretty interesting, right? You could see that we were doing well below our air quality standards, and then something happened in 2010. What happened? Well, in 2010, the DEP established the Columbia Wildlife Management Area Air Monitoring Station, and you can see where it's located right here. And they established this station specifically to assess whether pollution was coming across from this neighboring coal plant in Pennsylvania. So the Portland Generating Station was a coal plant in Pennsylvania, Mount Bethel, Pennsylvania. It's producing energy. But we also thought that it was producing air pollutants, right? And residents in the nearby Knowlton sometimes would wake up and there would be ash or dust or soot on their cars. And we thought that this coal plant was a significant producer of sulfur dioxide emissions. So we established that monitoring station in 2010, and we saw this big bump up. Right? You see this increase in concentrations directly related to establishing that station and the pollution that was being produced by this coal plant. Right, this coal plant had no scrubbers. That was one of the big ways of reducing emissions of coal. Right, establishing those scrubbers that remove the sulfur dioxide before it gets emitted. This plant did not have them. And this is another reason why we needed more of a federal agency or a federal response to air pollution, right? The initial iteration back in the early 60s really left it more up to the states to clean up their air pollution. But we find right here that pollution does not stay within the state. It travels across state lines, right? We know those westerlies, that air generally in this latitude, that air is going to flow from west to east, and it'll bring pollution across state lines. So we needed that federal response, which is why in the 1970s, they revamped the Clean Air Act to put the EPA, a federal agency, in control. So what New Jersey did is they collected this data, essentially made the case that this pollution is coming over from Pennsylvania, and they petitioned the EPA to do something about it. And the EPA ruled, and they said that this Portland plant must reduce their emissions by 60% by January 2013 and at least 81% by 2015. In response, the plant just decided to shut down, right? They did their own cost-benefit analysis, and they said it would be too expensive to install these scrubbers or to change it to something other than coal, and they decided to just shut down, which they are free to do. But once it shut down, you could see we had that reduction in CO2, right? It shut down in 2015, and automatically our emissions are back down to where they should be, below standards. And then we also saw a health effect, right? After the station closed, the likelihood of low birth weight went down 15%, and the likelihood of premature birth decreased by 30% in areas downwind of where this coal plant was, right? So again, highlighting those atmospheric processes, highlighting the need for a federal response here, and the health effects of this air pollution is an example right here. So again, besides that little blip in 2010, we are below ambient air quality standards for sulfur dioxide. But this also highlights the need of monitoring stations, right? Because without that monitoring station up there, we would just assume we were below standard, right? So you're only as good as the data that you collect, right? This is only as good as the stations that we collect, stations that we have, and the data that we collect, and we make sure that we have good coverage across the entire state. Okay, so let's look at our particulate matter. Right, and again, we are doing fairly well statewide. We are below ambient air quality standards that you see there with our particulate matter. And again, this is important because that particulate matter is particularly dangerous to human health. Where we are above standard is ozone. Right, we've been above standard for a number of years, but we are getting better. You see, we are decreasing our ozone. And again, particulate matter and ozone are difficult because there are multiple sources of it, right? With ozone, it's the different VOCs, it's the nitrogen dioxides that are all producing ozone, and it's hard to manage all of them. We've reduced our emissions in cars, which has gone a long way to reducing this, and we're also reducing emissions or putting those scrubbers in industrial processes that are helping to reduce ozone. But I think a lot of this is traffic related, and we are improving our emissions in cars, which is helping. You can see the number of days on which we've exceeded these ambient air quality standards is pretty much going down each year to where we are almost right there below standard throughout the entire year. So that's a little bit about how we monitor our air pollution and our ambient air pollution, right? Our air around us, particularly outside, and the status of our air. It's pretty decent, right? You think of New Jersey as kind of a polluted area, and there are very polluted areas, but statewide, we are doing a good job of bringing our air pollution below these federal ambient air quality standards. Which brings us now to indoor air. So, why is indoor air important? Well, we spent a lecture and a half talking about ambient air outside, but it's estimated that people spend about 90% of their time indoors. So if they're going to be exposed to pollutants or air pollutants, they're going to be more likely to be exposed to indoor air pollutants than outdoor air pollutants. Right? And this is important because studies of human exposure to air pollutants indicate that indoor levels of pollutants may be 2 to 5 times and up to 100 times higher than outdoor levels. So as a result, indoor air can have a huge effect on the quality of human health. So what makes up indoor air pollution? Well, a part of it is that outdoor air pollution or that ambient air pollution. And the extent of that is going to vary based on the location of your building, the building construction, and its ventilation, right? Generally, if it's closer to a major roadway where we have transportation related emissions, right? Those nitrogen oxides, particulate matter, ozone, closer to that, we're more likely to have a bigger influence of our outdoor or ambient air pollution. Building construction, your older homes are generally a little bit leakier, right? They're going to let more outdoor air in, which isn't always a bad thing, right? Sometimes that ventilation is really good, but if that ventilation is high in outdoor air or ambient air pollutants, not a good thing. And then ventilation in your homes, depending on how your home is ventilated, will impact the impact of outdoor air pollution indoors. Now, they did a study in Boston where they looked at different types of living situations to see if there was a difference, and they did find a difference between renters in apartment buildings and homeowners in single-family homes or multifamily units. The red here is the contribution of indoor air pollution. The gray is the contribution of outdoor air pollution in the overall pollutants within the home. And they did find something interesting that apartments or renters generally had a larger contribution of indoor air pollution than in single family units. And this was due to a number of things. Your apartments are generally smaller than homes. They generally have less ventilation. An example, range hoods. You usually don't find those in apartment buildings that you would find in a home. And smoking habits were actually different. People were smoking more in their apartment buildings. And that all explained this difference that we saw, right? And generally, what is also common is that if we are looking at indoor air pollution as the increase in indoor air pollution, as you see an increase in indoor air pollution, it's generally related to indoor sources, right? So where you had high pollution, which would be over on these bars over here, where there was a high level of pollution in your living space, most of that pollution was due to indoor sources. What are these sources? Well, they could be a number of things. Your cooking appliances, tobacco smoke. If you're smoking, don't smoke indoors. It's terrible. Cleaning products, furnishings and furniture. Right? They can off-gas VOCs, which we'll talk about. Pesticides kept in the home or in the garage connected to the home. Personal care products are all sources. Indoor sources, right? We kind of talked a little bit about outdoor sources already, particularly distance to traffic or major highways, but distance to industrial sites or contaminated soil can also play a role. So those are your main sources. Then your exposure, again, is kind of going to vary based on what we just saw, where you live, your size of your living space, and your construction of your building, right, are all going to play a role. And your activity patterns, as we're going to look at. So if we're talking about sources of indoor air pollution, a lot of times what we are concerned with is that PM 2.5, that particulate matter below 2.5 microns in size, right? And that forms from mainly combustion. So any sort of combustion that and mainly combustion that involves organic material, so fossil fuels, uh, will produce these small particles that can be dangerous to human health. Right? So we could find this in the home in a number of ways. If you have gas heat, like a gas furnace, a gas stove with cooking, they are going to produce PM 2.5. Fireplace or a wood burning stove is going to produce PM 2.5. Even candles, right? Lighting candles produces PM 2.5. It's it's a bit scary and it's a bit of a buzzkill because a lot of these things people like to do. But the reality is that they do emit pollution. Now, that's not to say you can't do them, and we're going to look at ways that you reduce that pollution. But it is something to recognize, right? And here's an example right here. If you look at, we're going to focus on cooking, right? I enjoy cooking. I know a lot of people that love to cook, but cooking is an indoor source of PM 2.5, right? And if you remember that, we can go all the way back to here. Sorry, this is going to take a little bit, right? If we are looking at ambient air outside, our national ambient air quality standards are 12 micrograms per meter cubed, right? So remember that 12 micrograms per meter cubed. We want to be below that. That yearly average is what we set as healthy for humans in the ambient air. If you go back to here to cooking, right? If you're frying and grilling foods, you're producing 69 micrograms per meter cubed, at least done in this study. So way above that ambient air standard. Look at smoking. Look at if you smoke indoors. Look how high that is, right? Or vaping using hairspray. So by cooking indoors, you are being exposed to more particulates than if you were standing. This was done in London. If you were standing on the London roadside with cars going by. So amazing that you don't, and it's something that you don't really think of, right? The potential hazardous effects of cooking on your health due to particulate air pollution. Now, this is not to say not to cook, right? But there are ways you can reduce the exposure to particulates when you are cooking, right? One of the ways is to cook on the back burner instead of the front burner. You want to use a range hood if you have it, right? So, in a lot of homes, they will have a range hood that is going to ventilate the emissions, we'll say, as you're cooking. It's going to ventilate those particulates up and out through the house. Open a window, right? You can open a window while you're cooking, get better ventilation going through. Electric stoves are better in reducing particulate matter, right? And other pollutants that are produced in cooking, right? So, for example, a gas cooking produces about twice as much PM 2.5 as an electric stove. It also produces nitrogen oxides, carbon monoxide, and formaldehyde, which isn't produced in an electric stove. So, if you have an electric stove, that is even better. And then something that I guess, we'll encourage in all these slides is to use an air purifier, right? I like to cook. I'm still going to cook, but I will use an air purifier. I will open up a window, try and cook on the back burner as ways to reduce the impact of this. And now when you are a standalone air purifier, you want to make sure that it has a HEPA filter, right? So, and we'll look at filters a little bit later, but that HEPA filter is going to be effective in filtering out these very, very small particles. So that's something to look for if you are interested in purchasing an air purifier. So again, indoor combustion is one of the ways that we get a lot of indoor air pollutants, and that's coming from all these things that are burning, right? Gas furnaces, gas stoves, fireplace, wood burning stoves, candles, cooking, right? Especially gas, cooking over gas. Another thing, wood burning stove or fireplace. Now, this hits hard to me because I love wood burning stoves and I love fire, like having a fire indoors. I do. I think a lot of people do. There's just something nice about it. The downside is that it does contribute to indoor air pollution, right? A study done in England looked at wood burning stoves. They saw that most stoves were lit for about 4 hours at a time, and during that time, average PM levels, PM 2.5 levels, rose to between 27 and 195 micrograms per meter cubed, right? Much higher than that 12 excuse me, that average that we saw that we want to shoot for over the course of the year. Um, so it does produce this particulate matter. And again, it's something to be aware of. I'm not saying don't have a wood burning stove, don't have this, but there are ways you can reduce the amount of emissions, right? EPA now has certified wood burning stoves that limit the emissions, and there's a database right here. You can Google this, right? So they're going to help limit the emissions. And again, use that air purifier. If you're burning wood, don't burn wet wood. It gives off more gases. Burn dry wood, and also try and make a hot fire, right? The less efficient your combustion is, the more particulate matter you are producing, right? So if you have a very hot fire, it's going to be more efficient and you're less likely to produce these particles, right? So if you're burning, burn a nice hot fire. Candles. Again, I'm being a real buzzkill on things that people like in their home. But if you look at candles, they are also producing this PM 2.5. Here's a study that they did, and they looked at different types of candles, paraffin candles, and a beeswax candle down here. They got different sizes and how many wicks were lighted at the time. And this was the concentration of particulates that were being produced. And it varied. Some were very, very high, as you see here. Others were were not so bad. But another interesting result that they found is that your particulate matter increases drastically when you blow the candle out, right? When you snuff it out. That's when you see this high increase in particulate matter, and then it slowly decreases. And this is hard to see because you can't really see this matter. It's so tiny that you don't notice it. So you think you blow your candle out and it's nothing. But it is contributing to potential negative health effects in your home. So again, I'm not saying you can't burn candles, but if you want to do it and try and reduce some of your exposure, you may want to limit the number of candles that you're burning at any one time and the length that you burn them. Maybe just keep it about an hour max, right? You want to reduce your exposure. Beeswax candles perform better or have less emissions than paraffin. And again, try and use that air purifier, right? Filter out these pollutants in your home as you're producing them. Like that air purifier is kind of like when we talked about that emissions control, right? Those scrubbers or things like that. It's that same idea, right? Where you're still emitting, but you're cleaning up your air in that process using that filter. Okay, so those were sources of combustion, and we're really focused on PM 2.5. Combustion also produces volatile organic compounds that we've talked about, right? They're the precursors to ozone when we're talking about tailpipe emissions and outdoor ambient air. But volatile organic compounds are also some of those HAPs that we talked about, like hazardous air pollutants. Some of these are very toxic, very damaging to your human health. Now, sources of VOCs in the home can be numerous. Paints, varnishes, caulks, adhesive can be sources of VOCs. Carpeting, especially new carpeting, that new carpet smell, it smells great, but some of that smell is these VOCs, which aren't good for you. Vinyl flooring, composite wood products, upholstery, air fresheners, again, smell nice, not great for you. Cosmetics, smoking, dry cleaning, cooking, which we just talked about, burning wood, which we just talked about, all sources of these VOCs. Now, the most common ones that you are going to find in the home are trichloroethylene, formaldehyde, benzene, xylenes, and ammonia. And these are some of the lists up. See some of the VOCs that you might find in the home. Again, these are the most common ones. This is kind of hard to see. You don't need to know this. Just know generally VOCs, right? So ways you can reduce your exposure to VOCs. Well, one way is to only buy what you need when it comes to paint, solvents, and adhesives, right? These chemicals are off-gassing, right? They may leak into the air and they may leak these VOCs. So if you're going to buy them, try and buy only what you need. If you're going to store them, try and store them either in a garage or even better, a shed away from where people spend a lot of time. Dispose of your unused chemicals, and there are ways, waste collection sites that you can Google to try and find in your city or county, right, to where you can dispose of these chemicals to just get them out of your house. There are low VOC options for paints and different furnishings that you can Google and look up. And when buying new items, especially wood items that have finishes on them, you may look for the floor models that have been in the store for a while. And the longer they have been in the store and exposed, the more off-gassing, so the more VOCs that have been produced. So when you bring them into your home, they may not be off-gassing as much. All right. So ways you can reduce your VOC impacts in your home. Now, there is some interest in looking at plants as VOC purifiers, right? There have been some studies done, but not a whole bunch, right? And there needs to be more studies about using plants in your home as to improve your air quality. There has been some work done on a large scale where having an entire wall filled with plants has an effect on reducing air pollutants. And they're looking at that more for outdoor applications, so sides of buildings being just covered in plants in cities that are reducing pollutant loads. But on a small scale, in your home, there hasn't been a lot of work done. However, a NASA study did find, that should be find or found, two plants that work to reduce levels of all 5 of those most common VOCs from the indoors. And remember, these are our most common VOCs right here, right, that you may find in your home. Those two plants are peace lilies and Florist chrysanthemums that you see down here. And both of these were effective in reducing these VOCs from indoors. So if you guys like plants, I would encourage you to maybe pick up some of these, put them around your home, and they'll help to reduce any potential VOCs that you have in your home. Okay, another important pollutant that we don't really talk about, especially with outdoor ambient air, but is important in the home is moisture. Moisture is important because it contributes to the growth of mold, right? Fungal spores and mold, fungus that grows. And this could have an effect on your health, right? It can irritate your eyes, nose, mouth, and throat. You can have allergic reactions. It can trigger asthma, right? Nasty stuff. So because of that, you want to control moisture. And how you do that is obviously, you want to fix any leakages in any of your pipes. A dehumidifier is a good thing to have to reduce moisture out of your home. And you want to have good ventilation. And this is where we're going to get to air filters right here. I talked about HEPA filters earlier. That's what you want to have in your personal air purifier if you have one, if you're going to buy a standalone air purifier. But if you have a ventilation system in your home, right, you are going to have air filters in there. And your air filters have different MERV ratings, and they're related to the size of particles or the quantity of different sizes of particles that they will filter out, right? So generally, a higher MERV rating is going to filter out more particles and more smaller particles, right? So it's better to have a higher MERV rating. However, there are some considerations, right? The higher the MERV rating, the thicker your filter is, and the more energy and bigger fan you're going to need to push air through that filter. So you can come up into situations where you have a high MERV filter, and now you have extremely high energy requirements and energy costs because you need this giant fan to push air through this filter. So really, in a residential setting, these HEPA filters aren't necessarily needed, right? There, the downside is the extra energy costs associated with it. However, in places like California where there's frequent wildfires, they are advertising homes with these HEPA filtration units because, right, there is the frequency of wildfires and that contributes to poor air quality, right? But for most homes, you don't need that HEPA standard. That's something MERV 17 or higher. You usually see that in hospital settings. But the higher you can get in this MERV rating, the better you're going to be at filtering out not just potential mold spores that we talked about here, but those other particulate matters and other chemicals that are hazardous to your health. The last thing I want to talk about in terms of indoor air quality is radon. I think this is the last thing. I don't know if I touched on. I don't touch on carbon monoxide. Okay, I'll add carbon monoxide without a slide. So, radon is a colorless, odorless gas that's formed from the decay of natural uranium that is found in the soil and water. Now, exposure to radon gas is the second greatest risk for the development of lung cancer behind smoking. Right, so it is an important pollutant to be considerate of. Now, you are more likely to have radon in your soil or in your water, groundwater, depending on the geology of the region in which you are found. So zone 1 here, and it's typically related to, a lot of times it's related to coal, right? So if you're areas where you may find coal in your soil or deeper down coal deposits, it may be more likely to be exposed to radon. You might see here in like Appalachia, right? So zone 1 are counties with predicted average indoor radon screening levels greater than 4. So this zone 1, this purple here, that's where you're more likely to have higher levels of radon, which isn't great, right? You can see some of that is in New Jersey, although down here in the coastal plain area, it's less, more northern New Jersey. So again, radon's important because it can contribute to lung cancer, other health diseases as well, besides just lung cancer. Thyroid problems can be associated with radon. But there's relatively easy ways to test for it. They make radon test kits that you can buy online or in hardware stores. They make short-term test kits that measure anywhere from 2 to 90 days and longer-term kits that measure more than 90 days. And these test kits will tell you if you have radon in your home and the amount. And then if you do, there are ways to mitigate it, right? And mostly those mitigations are giving this radon a pathway for it to travel up and out around your house, right? So how radon enters the home, it's entering through the soil or the groundwater. It can come up through your well water if you have well water. It can come up through cracks in your foundation or through a sump pump, through your windows, etc. Up through your shower, even, right? Coming up through that your water system. So how they mitigate for radon is essentially they give radon an easy access point for it to travel up to, right? So they create a system for this radon to enter, and then they have that enter up through a little mitigation system and out outside of your home. So it never goes up to your living space, right? It's contained in this mitigation system, right? And there are contractors that can install this for you. So that's it in terms of indoor air, right? I think I gave you some important things to look at, right? A lot of it is, common things that you might do: cooking, candles, fireplace, paints, carpeting, all this stuff that you might find in your home that do produce organic or pollutants. Last thing I said that I don't have a slide for, but that I want to touch on is carbon monoxide. I talked about it in the previous lecture. But especially if you have gas in your home, gas furnaces, gas stoves, this combustion also produces carbon monoxide, right? Like I listed here. And again, that is potentially very dangerous, deadly in your home. So have a carbon monoxide detector. Make sure you have that in your home. It will detect that. It's odorless, colorless, so you won't see it, you won't smell it. But that detector will alert you if there are elevated levels of carbon monoxide, and then you can address that, find the source, call a contractor, and they'll find the source and remediate that for you. So that's it. A little bit about the status of air in New Jersey, our indoor air, why it's important, and some of the ways that we can help mitigate for it. I will see you guys next week.